Hello, we're Team 6. We studied about Seoul Metropolitan Government. Our team members are 하준혁, 김병준, 최지성, 김찬주, 김예빈, 박수진. Last week, our team looked into temporary works and earthworks. On this week, we will study about foundation and framework. This is the contents for this presentation. I will present about the characteristics of construction and its plans, and select the foundation method and subterranean framework method appropriate for it, and present how to preserve old building, one of the biggest features of the project. 세종대로 중구, where our site building is located, is often congested because it is a downtown area, and especially during rush hours, traffic is often restricted, so making it difficult for ready-mixed concrete truck places to wait. In addition, Deoksugung Palace is located right next to the site, so it has site characteristics that are sensitive to environment and safety. So this site character can cause the delay of casting, and furthermore, it can cause delay of total construction period. As for the characteristics of the project, NGOs monitored the poor construction, and the owners and supervisors demanded high quality. So if there were some demerits of method, the solution is needed. Based on these circumstances, project teams worked on improving quality, safety, and environmental management, and came up with appropriate measures for concrete construction. This included setting the time for laying, observing quality tests, proper processing of concrete residues, and establishing plans for winter quality control. This has contributed to ensuring the construction and safety of the entire project. And most of all, the design has already been changed several times and construction began long after the original time to be completed, which has caused a number of political and economic problems. So the most important part of the total construction plan was to reduce the construction period to the maximum. So with this purpose, Met Foundation and FHTD are selected. Now, let's look at the two techniques used in the field. Met foundation is a form of foundation that supports the entire building with large concrete plates and distributes the weight. It is applied to high-rise buildings where loads are concentrated. When applying a met foundation, make the weight of the soil removed from the excavation in such a way that it is close to the weight of the building. This ensures that the load on the soil remains almost unchanged and minimizes settlement. Met foundation was constructed through joining and contemporary ramp, and this allowed minimal interference and facilitation of equipment movement. The met foundation requires a well to collect water by installing it in the aquifer and laying a porous collection tube on the side wall. As this well, a steel collector well was used as another way to shorten the construction period. In order to install existing collector well, concrete had to be poured twice, but steel collector well, which is used in this project, can be installed just by installing rebars and lay concrete immediately. It is easy to construct and has the advantage of shortening the construction period. As I mentioned, the most important thing was the decreasing construction period. For this reason, the ribless was selected, because this ribless is light so easy to handle and is to dismantle, and the even cost has been reduced. Also, the construction site was narrow due to the top-down method, but the ribless minimized the installation space, so there was no big problem in installing. And because it was the construction of the Seoul Metropolitan Government, surveillance at NGOs was severe. These problems were also solved because the use of ribless improved work safety and prevented poor construction. And I'll present about subterranean framework. Originally, in turnkey contract, the FSHTD method was proposed, FSHTD means hanging the form and support together from top to down. So this is support and this is rappelling form. And this is the sequence of the method. The point is lowering the support after pouring concrete of upper floor, like this. The disadvantage of the method is lowering the support with rappelling roof. Due to the support drop, it causes dangers to workers, and this method lowers the construction ability. It delays construction period and also costs a lot. So the new method was adopted. It's form hanging top-down method. This method lowers only concrete form, therefore it can reduce the dangers of support drop, and it can remove the interference of supports. It also assures the higher construction ability. This is the construction sequence of form hanging top-down method. First, excavation and install beam form and slab form, and arrange the steel and install rappelling hole, and pour the concrete and remove support. After that, excavate and install equipment for rappelling. Finally, lower the beam and slab form. There is a problem with interference with FHTD and excavation construction, so this had to be resolved in advance. In excavation construction, there is a difficulty in framing work when there is a blasting work on the other side. And secondly, includes the possibility of soil inflow into the frame construction site during earthworks construction and creation of slope. So these three problems got solved by the joining. Joining could secure free space so it can lower the interference between the zone and make an order for zone so it make high construction ability. And I will talk about preservation of the old building, which is the most characteristic part of this project. Since the building area has become much smaller after several design changes, it was necessary to develop the basement of the old building. After various discussions, the government decided to implement the USEM construction method that allows the state-of-the-art government to secure underground space while preserving and reinforcing the old building, the cultural asset. USEM is a method for expansion and renovation of existing buildings. This method transfers the load from the existing foundation to a separate structure while preserving the existing building. It then builds underground structures in the lower part of the existing building. Okay, let's watch a video about this method's process. The first step of the sequence is micropod construction. It was designed by reflecting safety factors as much as possible and setting the importance higher. After pod construction, structure reinforcing work was done. This reinforcement was carried out in column, beam, and floor on the first floor of the main building, and also in seismic structure of concrete walls. It then moves the load of the building from its original base to a micropod they built, which is too dangerous to move at once. Therefore, the main building is divided into three parts, and each part is transferred by 25% of the load and moved over, so a total of 12 times. This is called preloading. After the load is over, the frameworks of the basement floor of the main building will be constructed. Until this construction is completed, the main building is truly managed because the cultural heritage preservation and management standards allow only 3 millimeters of error. Therefore, 16 locations are installed for automatic measurement and 16 locations for manual measurement are installed to measure the amount of subsidence of the structure. This is measured in real time and can be viewed through SMS. To sum up today's presentation, there was this problem with our construction site. But all of this has been done through zoning. Zoning even had the effect of the construction period shortening constructional geometry and enhance construction ability. Okay, this is the end of our presentation and team members' roles are followed this. Now, thank you for listening.